Okay, this is a good one. Number 9, this is easier than you think. It says the limit as x approaches negative infinity. All right, so now watch this. Negative 15x squared minus 6x plus 11 all over negative 5x plus 4x plus 2. Now this one you can almost solve intuitively. We're going to plug in a really, really large number, right? So what we have to determine is what are the dominant expressions or terms in this function? Well, let me ask you this. If I plug in 10 million for x, and let's assume I plug this all in, I'm going to get some ridiculously large number in the numerator. How much difference will this plus 11 and plus 2 make? None. Not when we're approaching infinity, right? The ratio of the top over the bottom, if I have 11 in the top and 2 on the bottom, it's insignificant, really. So we can almost kind of ignore those. When you're only when you're doing limits that approach plus or minus infinity. Only when you do limits can you do this. Because it's asymptotic behavior. There's an asymptote that occurs here. Likewise, what about this x term? Well, if I plug in 10 billion here and I square it, that's a lot larger number. And think about a trillion. What's a trillion squared? A lot larger than 6 times a trillion. And again here I have x squared and I have 4 times a trillion. Well, in other words, the dominating numbers are these leading terms. So I could treat this, because I'm plugging in infinity or negative infinity in this case, I could treat this like the limit as x approaches negative infinity of negative 15x squared all over 5x squared. But now when you look at that, what do you notice?
Reduce.
Yeah, this cancels with this cancels with this, and really it reduces down to 3.
What just happened?
Calculus.
So pretty much you
So
just
that's
take the big
Yeah,
one.
so now watch this.
factor it.
If you say, Mr. Adams, come on, this is some sort of wizardry.
Oh, I see.
Let's see. So if I say negative 15 x squared minus 6x plus 11 all over negative 5x squared plus 4x plus 2. All right, now I already know that there is a horizontal asymptote at y equals 3, right? So let's graph this bad boy. Graph, zoom, oh, come on, hurry up. Zoom, standard fit.
Dang.
Well, what? It can equal 3 in the middle, right?
Yeah.
Why?
Well, because of the way the function's written. Probably you could probably reduce this thing or something, but basically there's asymptotic type behavior, what we call M behavior, right? So as we look at this right here, it's never going to cross 3 as you approach infinity. Also, but really I think the limit is approaching negative infinity, so we're going to go in this direction. So now I'm going to hit trace. Watch this. Here's the number we got to look at. 2.2, 2.5, okay? And you say, Mr. Adams, well, let's plug in a really negative number. All right. Let's start at like negative 10,000,
Oh.
okay? Look at the table of values. What does that look like it's doing?
2.999.
Yeah, 2.999. So as I keep going and going and going and going and going, the only thing it's going to do is get closer and closer to 3. So you can see at 10,000, you already see this asymptotic behavior. You already see how 15x squared, negative 15x squared over negative 5x squared dominates this, this rational expression, right? Does that make sense? Okay. Yeah, but we're asked to approach negative